Now my friend will introduce himself.
Hello friend, myself Vikas Kami. Currently studying ICT diploma from SEM 3.
And our project name is square wave generator using OPM IC 741.
Now we start our presentation.
Let's start with our content. So first of all, we see a introduction, operation, component used and application, and the circuit diagram. So let's start with our introduction. So in introduction, a square wave generated using op-amp IC is a simple circuit that can be used to generate a square wave with a wide range of frequency and amplitude. It works by creating positive feedback loop that cause the output, the circuit, to switch rapidly between two voltage levels. And square waves generated using op-amps are versatile, inexpensive, and easy to build. They are used in a variety of applications, including digital, electronics, and clock generation. So now see our operations. In the operation, the square wave generator circuit work by using the op-amp to compare the voltage at it is not inverting input to the voltage it is inverting input. When the voltage at the non-inverting input is higher than the voltage at the inverting input, the op-amp output is standard high. When the voltage at the inverting input is higher than the voltage to the non-inverting is standard low. The capacitor in the circuit charge and discharge through the 1 kilo ohm resistor, causing the voltage at the inverting input of the op-amp to ramp up and down. So when the voltage at the inverting input reach the voltage at the non-inverting input, the op-amp output switch from standard high to low standard low. Let's see our component used. So in component we used to build a square wave generated using a 741 op-amp. We used IC 741 op-amp, resistor 10 kilo ohm and 5.6 kilo ohm, capacitor 0.1 UF and a breadboard and a jumper wire and a power supply of 12 volt. Now my friend Tejas Vargama will continue our presentation.
So now friends, I am going to continue our PPT. Now we can see our OPM IC 741. Here the 741 detail. The IC 741 is one of the most common OPM integrated circuit that perform operational mathematics operations and application. We can see there is our diagram that have 8 number of pins. There our 7 and 4 pins are our power supply pins, and 2 and 3 is our inverting non-inverting pin, that is our input, and 6 number pin is our output pin, and that 1 and 5 pin is our offset null pin, and that last 8 number pin is not connected NC pin. Now we can move to the register. We can use in our project 10 kilo ohms resistor and 5.6 kilo ohm resistor. We can see that our characteristics of resistor, it can opposition to current flow measured in ohms and maximum power dissipation without damage, and random voltage fluctuation measured in microvolt. And we can see resistor is our passive component in a two terminal electric component implementation in our project, and it used to reduce the current flow of the which we given in our circuit, that is 12 volt. Now we can move to the our capacitor. So we can use 0.1 microfarad ceramic capacitor. We can see it is 0.1 ceramic type capacitor. In a capacitor we can see there is more type of capacitor, electrolytes and ceramic, but in our circuit we can use ceramic capacitor between pin number 2 to ground. We can in the input, so our the waveforms of the op-amp IC is saturated. Means saturated is that is stable, not fluctuated. So our waveforms are clear, we can see, or we can see is the in our image, that is feedback register. As a feedback register we can use, And now we can move on the our last components, that is our breadboard and jumper wire. So we can prefer for our project square generator, breadboard and jumper wire for the connection. You can see here jumper wire is a very common wire connection, and for the very easy to use for the connection in breadboard. And we can use a breadboard because of this very easy to uh, assemble our components as per the circuits and all. And it's a very popular choice for prototyping circuits. Now we can move on the circuit diagrams. So that first circuit diagram is our multi-sim circuit that my friend and I can make on multi-sim. And our second diagram, our circuit diagram connection is that we can made in our circuit diagram as per our circuit. And that's video circuit diagram is given from the video reference link. Now our circuit connection photos, like you can see, there is a capacitor as per the toll from pin 2 to ground. And there's two orange jumper wire, that is our waveform channel 1 and channel 2 ground. And that's red and black wires are our power supply wires. And white jumper wires is our positive terminal of our channel 1 and 2. Now we can see that's a waveform. In a waveform we can see that our that sine wave is our input waveform that we can get from pin number 2. And that's our generated square waveform in from pin number 6 in our circuit. Now we can show that in a conclusion we can say that square wave generator op-amp IC using op-amp ICs are simple and effective versatile circuit, but have some limitations such as a high field offset voltage that we can get from the pin number 1 and 5 IC of op-amp IC. And a lack of stability and sensitivity to temperature changes. It can also goes to high heat. Now we can say our reference. So first, as I told that our video circuit diagram is from this video reference link. And our for more detail we can go to the this link of our circuit project. Now we can move on the our last page of ending our presentation. Thank you. Start our explanation of our circuit diagram that performed by my partner Itar Kenny.
Start our circuit explanation. First of all, we see op-amp there is a 8 pin, but we only use 5 types of pins. It's pin number 7, 4, 3, 2 and 6. Other pins are not required for our projects. So now pin number 7 and 4 are required to give a power supply into a op-amp, and pin number 4 and pin number 3 and 3 stand for 3 and 2 stand for input, and pin number 6 stand for output. Now we start our connection of power supply plus power supply. So first of all, pin number 7 and 4 is connected into a op-amp, and also connected on a breadboard. Now also connect our resistor and capacitor in a op-amp between pin number 3 into 3 in negative between 10 kilo ohm resistor, and connect pin and connect feedback resistor, that value is 5.6 kilo ohm, from pin 2 to pin 6. And connect pin number 3 between 10 kilo ohm resistor, and connect feedback resistor, that value is 5.6 kilo ohm, from pin 2 to 6. That connect our DCO, then connect our DCO channel 1 or 2. So channel 1 is connected at an input, and channel 2 is connected for a connected for a square waveform on a DCO screen. Our both channel ground pin is connected at a common terminal between capacitor and a resistor. Now our circuit is completed about the connection.
Now my friend Tejas will explain about the waveform generator.
And now I will explain waveform generate by the op-amp IC. Now we can see that our sine wave input waveforms are we can captured by the channel DSO pin number channel 1 that is connected at the input terminal 2. This is our input 2, and our channel 1 ground are connected at the common ground pin. That is our input signal that we can give in our sine wave, and our second channel that is our output pin, and output waveform are generated by our 6 number pin. We can connect our second channel positive terminal at pin number 6, and also that second channel ground pin are connected at the common ground, that our common ground are connected with our power supply, and we can connect our ground between resistor and capacitor. That and our waveform, we can say that our sine wave is our input waveform, and that captured by the channel 1, and our output waveform that connected at the 6 number pin of op-amp IC, that is our output square waveform. And we also connect feedback resistor between pin number 2 to 6 number pin of op-amp IC on our breadboard. As per the circuit, this is how our square wave generated by our op-amp IC.